Hello, hello. A few people watching the stream. All right. Where are you watching from? Hello. Shaho, where are you from? Uzbekistan. Sorry about that. Well, hello. All right. We'll give it a minute for people to give a chance to people to join in. All right. So we'll start. Welcome to this global Azure session on containers on app service and tips and tricks. My name is Guy Barrette. I'm a developer, coach, trainer. I'm based in Montreal, Canada. You can reach me on Twitter at Guy Barrette or through my company, Kubernetes Academy Online. I'm an Azure MVP, certified on Azure, on Google Cloud, on AWS, and also on Kubernetes and Terraform. In my day-to-day job, I teach Docker and Kubernetes. I have an offering through my company called Kubernetes Academy Online. Uh, Either through self-paced courses that you can watch on your own, or through live classes, North American time zones. So you can save $10 on my self-paced courses using this code, save $10. So I have a course on the Docker and Kubernetes fundamentals, a complete course on Azure, also another one on a smaller cloud provider called Linode and DigitalOcean, and coming soon one on Google Cloud Platform. All right, let's talk about Azure App Service. What's Azure App Service? Well, you may be familiar with Azure App Service. You may have deployed a web application before on App Service. So .NET Core app, a Java, or whatever language you want. But do you know that on App Service you can also run containers? There's a flavor of App Service called Web Apps for Containers that lets you deploy containers. So that's what we'll cover today, and we'll see a few tips and tricks. So what are the app service benefits? Well, you can run a Windows or Linux virtual machine. Since it's a platform as a service offering, you don't have to care about patching the OS. It's done for you by Azure. You get high availability, and also automatic scaling, and there's a load balancer built in, and it's compliant to all sorts of compliance. And what is web app for containers? Well, it's actually app service plus integration with container registries like Docker Hub and Azure Container Registry, where you can store your container images. You can run a single Docker image, so one container at a time, or you can run multi-container apps with the use of Docker Compose. You can run Linux and Windows containers. And what's pretty cool with running Windows container is that you can go around some of the limitations of app service. So app service lets you run your web application in a sandbox. And inside that sandbox, it's impossible to install drivers or register a COM objects, let's say, or install a tool. But by running Windows containers, you're able to basically build a container image, install all these tools, these drivers, register these COM objects, and then deploy that image on app service. So it's a way to get around some of the limitations of app service using Windows containers. Okay, let's start by creating our first web app for containers. So I'll switch to the Azure portal, and here I'll click on create a resource. And instead of selecting app service, what I'll do is inside the search box, I'll type web app for, and yeah, here it is, web app for containers. So let's select this and let's click on create. All right. Let me create a resource group. I'll call that demo. And my demo GB, let's say, yeah, that's available. And you see, by selecting web app for containers, instead of code being selected first, uh, Docker container is automatically selected for me. I can select my operating system, Linux or Windows. Linux is fine. Let me select a data center close to me, Canada Central. I'll create a new app service plan, let's say, demo plan. I'll use the default values here. Click on deployment. So far it's about the same thing, except now we have a Docker tab where we can select our container. So in the option drop box, I can select a single container or multiple containers using Docker Compose. I can select a quick start image, so it's an Nginx image. But if I open that drop down, I can select my image source from either a Azure Container Registry, Docker Hub, let's say a public image on Docker Hub, or a private registry. So let's select a Docker Hub here. Let's say I want to select the Nginx image here. And it's a public image, and that's about it. The other steps I can skip. I'll click on review and create, right? And click on create. So the app service plan will be created. So the virtual machine will be provisioned exactly like you do when you create an app service, standard app service. But instead of deploying your code, your compiled code, app service will pull the image from the Docker registry and run that image. So that should take, yeah, it's already ready. That's super fast. I'm still amazed at how fast it is when creating a resource in Azure. So here I can, it's basically the same screen that we have when we run a standard web application. So what I'll do, I'll come back to the slides and we'll take a look at the different uh, pages here. And so you can manage your Docker image here. Okay. So first tip, my container does not listen on port 80. So it's possible when you create a Docker image that it's possible to specify a port that is different than port 80, the standard port. The problem is that Azure App Service listens on port 80. So let's say you configure your container to listen on port 8080. How can you route traffic from the port that App Service is listening on, so port 80, to your port 8080 that your container image is listening on? So it's super simple. You click on the configuration menu here, and you add a new application setting. That new application setting must be called websites underscore port. So it's a magic string, basically, it's magic application setting. And you set it to port 8080. And that's about it. So let's go back to the portal. What I'll do is I'll pre-deploy a few applications to speed up the demos. So let me go to the configuration settings here, right? And I already created that website port with value 8080. So I know that my container that I deployed is listening on port 8080. Let me click on the URL, and voila, it works. Even though that container is configured to listen on port 8080, traffic is now routed from port 80 to port 8080. All right. That was tip number 1. My container does not start. Tip number 2, troubleshoot startup events using the startup logs. So in the deployment center, when you click on in the left menu, deployment center, there's a tab called logs. And in this tab, you'll see the startup logs. So just to be clear here, these are the logs that App Service creates when it tries to run your container, when it tries to pull and run the image. So these are not your application logs. These are totally different. These are really App Service logs, and they are super useful because if your container does not start, well, how can you troubleshoot? Well, the first thing you need to do is go look at these App Service logs. So inside there, inside these logs, you'll see a super useful information. Like here, we see that App Service is pulling the image that I configured. You can see that here the image was pulled successfully. So you may have an error here. So maybe you made a typo by typing the name of your image, or maybe the image is private and you didn't specify your any credentials. So these logs are super useful to troubleshoot problems at startup. And you can even take a look at the Docker run command that App Service runs to create an instance of your application. So we can see that it's running the image, mapping port 8080 to port 8080 that the container is listening on. So these logs are super useful. So let's take a look at these. I'm going to go here. I'm going to click on Deployment Center. Right. And click here on Logs. And I can see the startup logs here. You can scroll up a little bit. As I have the application logs also in the same in the same section, but these are super useful here. I can see that, let's say, yeah, pulling image here. The image was pulled successfully, and the Docker run command that app service created. So if your container does not start, the first thing you need to look at are these application startup logs. All right. Well, that was the startup logs for app service, but what about your application logs? Well, to see them, you need to enable the application logs, and you can stream them after that. So how do you do that? In the monitoring section, you click on App Service Logs, and you simply enable application logging. By default, it's turned off. You click File System, and you can set quotas so you don't store tons and tons and tons of data. So here, the default quota in megabyte is 35 megabyte. You can set also a retention period. So after 3 days, these logs will be purged. And after that, right below the app service logs that we just saw in the previous slide, there's a menu item called Log Stream. If you select that, you'll be able to stream the logs right inside the Azure portal. That's pretty cool. But you can also stream these logs inside a terminal by using the Azure CLI. You simply use the AZ web app log tail, then you specify the name of your web app, and then the resource group, and you'll be able to stream your logs right into a terminal. So that's pretty cool. So let's check that. If I scroll down a little bit and locate the app service log menu, I've already enabled it. So by default, it's turned off. Set some retention period, quotas. And if I click here on log stream, it's connecting and it will log my stream. So let's say, let me just, whoops, I don't want to. Let me do a couple of refreshes here. F5, F5, F5. You can see a few entries. Let me just try to, okay, I'll pull that out of screen. There you go. You have 5, and you can see that the logs are streaming. And I can also stream them directly in a terminal window. So here, what I'll do is I'll copy the command. You don't want to see me typing, and I'll paste the command. So AZ web app logtail, the name of our web app, and the resource group. Should take a few seconds. Starting live stream. Let me do a few refresh on the page. We should see, yeah, they're coming. That's pretty cool. All right. To stop the streaming, Control C, and that will terminate the batch job. All right. Let's go back here. Let me pull that up again. Right. Okay. I now need to troubleshoot app service. How can we do that? Well, tip number 4, you can troubleshoot using the advanced tools. In the development tool section, there's a menu item called advanced tool, and you can click on the link here that will open a new browser window with the Kudu advanced tools, basically, that let you see a few things. So let's take a look at that. Development tools here. I'll select advanced tools. Okay, click on go. That will open a new browser window. And here I can take a look at my environment. If I select here environment, I can see some very useful information like the app settings, connection string, the environment variables. So if you set some environment variable and let's say a connection string, something like that, then the connection to the database doesn't work, well, you can take a look at these directly from the advanced tools and make sure that everything's okay. So that's pretty cool. There's an SSH link here. If I select that, well, look at the bottom of the screen. SSH con close. Well, that doesn't work. So we'll see in tip number 12, the last one, how to enable SSH. So we'll come to that a little bit later. Bash lets you issue some command. Take a look at the files that are these files are located in the VM running your app service, your container. So we're not connected directly to the container here. It's really the underlying VM here. But I can take a look at the log files from there. If I see the log files, ls, I can, let's say, cat, let me copy this one, shift insert. I can take a look at the logs right from here also. So that's pretty cool. And speaking of the logs that we saw earlier, if I select log stream, well, I can stream the logs also right into this browser window. So that's pretty cool. Let me do a few refreshes. F5, F5, F5. We should see them. Yeah. Here are they. Here they are. Pretty cool. So that's pretty interesting. And we'll come back to the SSH section or tab in our last tip. Okay, I'm going to close this. Let's go back to the slides. Up. I need to set some environment variables. So your container needs some settings. You want to pass these settings through environment variables. How can you do that? Well, tip number 5, it's super simple. You simply set a new application setting, and these application settings will be injected as environment variables inside your containers. So you simply click on configuration and add a key value pair here. So let's see configuration. Let's take a look. I already created one called hello with a value of world. And if I take a look at my container, if I click here in the left menu, server environment, this will list all the environment variables. And we have our hello world environment variable. So that worked. Pretty cool. Oops. How can we set app setting JSON parameter from Azure portal? I'm not sure what you're asking. Maybe the same as we do with Norbert Weta for containers. Yeah, the behavior, some of the behavior when running containers are a little bit different when you run a standard web application. So some of these settings might be a little bit different than when you run a standard web application. So I'm not sure exactly about how to answer your question, but that's there's a little bit of differences here. All right. Now, setting values from using environment variables is cool, but let's say I want to hide some of these values, and I would want to retrieve them from Key Vault secrets instead. Is it possible? Of course it is, and that's our tip number 6. You can set environment variables from Key Vault secrets. So there are 3 steps here. The first step is to create a managed identity. So you create a managed identity for your app service. Next, you create an access policy, basically granting access to that managed identity. And the third step is to create an environment variable that will pull the secret and inject them as environment variables. So let's see how to do that. So the first thing is to create that managed identity. In App Service, you click in the settings section on Identity, and you simply turn the status of the system assigned identity from off to on. And that's it. You click save and you just created your system assigned managed identity. It's that simple. Step number 2, you need to grant access to that managed identity. So how do you do that? Well, in Key Vault, you select the access policies setting, and you click on Add Access Policy. And you can create an access policy for keys, secrets, and certificates. In our case, what we want is to assign a policy for secrets. So you select the secret dropdown and you select what access you want to grant. In our case, we just want to give read access. So I selected get and list, and then click on add, and this will add the access policy. Now, you need to select the service principal, well, the managed identity. So you after selecting the permissions, you click on select principal here, non-selected, and then you select, you search for your managed identity that you just created. It will be named with the name of the web application that you created. So in my case, Cure Demo 1. So select it and then click Add. Now, back in App Service, you need to pull that secret. But how do you do that? You need some kind of a magic string. And this is the magic string. You create a new environment variable, but the value is set to that magic string. It's at Microsoft.keyvault, and then secret URL, which is the URL of your key vault. So something.vault.azure.net / the type of object that can be retrieved from Key Vault. In our case, it's a secret, and then the secret key. So we don't see the value of the secret. The app service will pull the value from Key Vault and inject that value as an environment variable in our running container. Sorry. So this syntax always pull the latest version of the secret. Well, that's a good question. This will be injected when the container starts. So if your container is running and the secret was injected, and then you change the value of that secret in Key Vault, well, the new value will not be injected automatically. You'll have to restart your container, your app service, to pull that new value. All right. So quickly, let's take a look at this. Let me just yeah. So I'm going to search for my Key Vault. My Key Vault is called Global Azure Key Vault. And here's my secret, LOKV, right, that I created earlier. But what you need to do is create this access policy. So let's say if I create a new one, I would click here on Add Access Policy and set the permission for the secret. So let's say Get on List, and then select to who I want to grant access. So I'm going to click here on Non-Selected. And here, I'm going to search for my keyword demo 1. That's the name of my app service that is running my container. I simply select it and click Select and Add. That's as simple as it is. So let me get out of there and go back to QR demo. Look at the configuration, the application settings. And here's my application setting from KV. If I take a look at the value, it's that magic string here. If I click on the edit pencil, here's my secret string here at Microsoft.keyvault, and here's my the URL of my key vault, the type, and the key. And let's take a look at the value from KV, and you can see that the value was correctly injected. That's the value that I set in Key Vault. All right, pretty simple, and that's something you should do if you have secrets that you don't want to show to your team, or maybe it's a connection string or something like that. All right. Deploying just one container is a waste of resource. Well, you can pack more containers in your app service or web app for container using Docker Compose. So what's Docker Compose? There's a Docker Compose file on the left of the screen, and basically it's a YAML file that lists all the containers that you want to run at the same time. So if your application is composed of multiple images, let's say a front end, a web front end, and then a back end or a database or something like that, or Redis cache, let's say, Well, you can create a Docker Compose file and then deploy that Docker Compose file. So we saw earlier when we created a new web app for containers, we selected a single container. But if you select Docker Compose, right, you upload that Docker Compose file, and App Service will pull all the containers that you define in that Docker Compose file. So it's a great way to pack you can basically pack more resources inside your app service plan. So let's say you created a virtual machine or app service plan with 3, 4, 5 gigabytes of memory. Well, running just one container might be a waste of resources. Sorry. By running multiple containers, well, you get more bang for your buck, basically. So let's take a look at that. Sorry. That's our tip number 7. So let's open Compose 1. And if you take a look at the deployment center, I can see that the container tab is Docker Compose, and this is my Docker Compose file. And if I take a look at this file in VS Code, well, it has 2 sections, well, 2 containers. Azure Vote Front, which is the front end that will pull an image, a web service, basically. And this container will listen on port 80 and have a second image that is a Redis cache. So every time we will vote, the code will connect to the Redis cache and basically increase a counter. And this one, what's super cool, this one is not exposed on the internet. It's totally private. So I can see here I have a mapping. That's the external port 80, and the container is listening on port 80. This one only listens internally on port 6379. But you can't expose multiple containers because app service listens only on port 80. And we'll see how to get around that in the next tip. So anyway, let's go back here. So if I select my Docker Compose app, that's my front end. I can vote for dogs, and the code will save the counter basically to the Redis cache. And there's no way from me, from the outside app service, to connect to that Redis cache directly. All right. That's great, but what if I want to expose the other containers over the web? We just saw that only one will be exposed through port 80. Well, what you can do, you can use an Nginx as a reverse proxy. So how does that work? Let's say we have two containers that we deployed. These are 2 services. They can be APIs or something like that. What you do, you put you front them with a reverse proxy. That reverse proxy will listen on port 80, and then through configuration, will route the traffic depending on what the user or what's in the URL. And the traffic will be routed to either, let's say, LO1 or LO2. So here, to the right of the screen, I have a Docker Compose file, and we have 3 services, 3 containers. The one at the bottom is the reverse proxy. right? It's listening on port 80. And the other two, LO1 and LO2, are not exposed directly on the internet, but through the use of a reverse proxy, we can route traffic. So how can we do that? Let me first open VS Code, reverse proxy. So you create your configuration using an Nginx configuration file, basically. So in our file here, let's say we have LO in the URL. Well, that call will be routed to the second image or the first image. And when we have another string, let's say bonjour, it's routed to another image here. So you create these routes in a Nginx config file, and then you create your Docker Nginx Docker image here. So it's super simple. You copy the config information inside your Nginx image that you're building, and then you will deploy that. So you create your config and then create a Nginx image, basically, that you will deploy in your Docker registry. Now, Microsoft just, released a few months ago a proxy that is built in .NET, and super cool. It's called Yapper. Whoops. Yapper, and it's a lot like Nginx, but it's built in .NET. So you have the it's open source, and you have the source code. So here, this is my Yapper proxy project. What I'm doing here in this Docker file is simply building an image using the .NET project, the C# project, and the settings. The route that we saw earlier that we configure with Nginx, well, the same configuration you create in a JSON file with your Yapper project here. So you push that to an image, and then this listens to the internet traffic and then route the traffic. So let's take a look at this. Reverse proxy. So here, if I take a look at my deployment center, take a look at the YAML file that I deployed. So I deployed this reverse proxy, the Nginx reverse proxy that listens on port 80. That will route the traffic depending on what we type in the URL. So let me click here. I don't have a default route, but if I type, let's say, hello, you see that's the ID of the container, ends with 9D. I typed hello. What if I type something else, bonjour, which will route to the second image? You see, it's different. So the routing works. That's pretty cool. And Nginx and Yapper are super small containers, so they won't take much resources from your web deployment, web application. All right. I need to persist files outside the containers. Well, tip number 9, you can persist data inside the app service VM. So there's a feature of app service called app service persistent storage. It's a you enable it by setting the website's enable app service storage to true. Click on the run button here. Yeah, that's better. And basically that enable you to save data and to read and save data on the app service VM directly outside your container. Container are ephemeris, so you should not store any data inside your containers. You should always find a way to store data outside your containers. All right. So after you enable that, there's an environment variable called web app storage home that will be mapped to the home folder of inside your app service VM. And then you simply create a mapping for your container to be able to read and write from that folder. So how do you do that? Well, you need to create a Docker Compose file. So you can't do that directly using a Docker file. You need really to use a Docker Compose file. But what if you have only one container that you want to deploy? That's totally okay. You can use a Docker Compose file and deploy a single container. So here I have my container that I'm deploying, my keyword image here, and I'm declaring or create a volume using this web app storage home, and using a folder name, let's say web app storage, and in green that's the local folder that the code running inside the container will see. So let's take a look at that. So if we take a look at our, whoops, I'm going to change project keyword configuration. My website enable app service storage is set to by default is set to oh, I'm in the wrong project, sorry. Compose to pa-pum. So by default, this value is set to false. So you simply change it to true. So that's a value, a application setting that is built-in app service. And then what you can do is create a volume and mapping this a folder. So let's go here in my advanced tools. I'm going to click go. And select bash. I'm going to type ls. I created this web app storage folder earlier. So if I cd on it, web app storage, right? It's totally empty. I'm gonna create a file. So let's say hello world. I'm gonna type that to a file called hello.txt. Okay, the file is created. Perfect. So let's try to see it. I'm gonna open this, and this is my ND container that allow me to do some testing. So I have a menu item called File System Browser. So let's click here on Web App Storage, and here's my file. hello world. Oh, that worked. Pretty cool. So that file is stored inside directly on the VM that is running your app service plan. But you may want to instead to read and write files directly into Azure storage instead of writing to the VM directly. Tip number 10, you can map a path to Azure storage, either blobs or files or both. So how can you do that? In the left menu in your app service, you select configuration, and there's a tab called path mapping, step number 2. And step number 3, you add a new Azure storage mount. And you can mount a blob and a Azure file here. Blobs will be read-only. Okay, and Azure files will be read-write. So be careful here when you select the type of storage. Blobs are read-only here. So let's take a look at this. Up. Close that one. Close this one. Also. I think that's my first one. Yeah. Keyword demo 1, configuration. See, path mappings. I already created two mount. So let's say I want to edit the first one, blob. So I give it a name, select my storage account, select either blob or Azure file. You see, when I select blob, it said mounted blob containers are read-only. Okay. I select my storage container. So that's the blob container that is inside my storage account. And then I specify a path that will be seen inside my container. And for the Azure file, it's exactly the same. Instead, you select Azure files here. So that's pretty cool because inside your container, these will be seen as regular folders. So your code doesn't need to use any kind of SDK to read and write files to blobs or Azure files. It's seen as a simple folder here. So here I have my blobs, and have an image here that I previously uploaded to that blob storage. And here it is. And same thing for my files, right? So here's an image that was pulled from Azure files. So Azure files are read-write and blobs are read-only. Pretty cool, especially since your code doesn't have to use any kind of SDK. I find it very, very, very cool. Okay. How can I easily deploy a new version of my containers? Well, tip number 11, you can enable continuous deployment. In the deployment center section, there's a switch that you can turn on, allowing continuous deployment. By default, it's off. You can turn that off. So just to be clear here, this is not a full CI/CD pipeline. This will create a simple webhook from app service to your container registry. And whenever you push a new image to to your registry, what will happen is that that webhook will be triggered, app service will be notified, and then app service will pull the new image and restart your app service, or your web app for containers with this new image. So it's not a full CI/CD pipeline, just to be clear. But for simple scenarios, that will do the job. So be aware that when this will happen, when app service will pull the image and restart your web app for container, your app service, you may have maybe a few seconds or a minute of downtime during this process. So that might not be acceptable. You might want to do that manually during, let's say, off time, if you don't want any downtime. All right. I'm going to skip this one and go directly to the last one. How can I connect using SSH? We saw in the in one of the tips that SSH was not deployed or was not configured directly. We need to do a little bit of work here. So that's tip number 12, how to open an SSH session using a secure tunnel. Well, it's not magic. You first need to install an SSH service inside your container because there's something that needs to listen for SSH connections. Is that something that you want to do? Maybe, maybe not. You're opening a new surface attack window here. So don't do it if you don't require it. But if you require SSH access to your container, first install an SSH service inside your container. Then you need to do some configuration, and I'll refer you to the Azure documentation because there are a lot of steps, but they're clearly documented. And then you can open an SSH session using the advanced tools that we saw earlier, or using the Azure CLI to create a secure tunnel. So you create the secure tunnel using this syntax: AZ web app, create remote connection, and then the subscription name, the resource group, and the name of the application. And that will create a secure tunnel. That SSH session is not totally open. You need to create that secure tunnle first. So in a sense, it's better than having a wide open SSH service listening on to. And then you use SSH, and the first command will generate a random port, and you use that random port here to connect to your container. So let's take a look at that. Let's take a look at my where is SSH demo 1? So I deploy a container that was configured, and the configuration is I would say there's a few steps. Follow the documentation. There's a lot of stuff that you need to configure. It would be way too long to go through these in this presentation, but refer to the Azure documentation. So that's what I pushed inside this image here. And if I go to the advanced tools, and I'll click on SSH, And you see, now it's working. So I can type some commands here. I can look at some files. Uh, so cd shift enter. Yeah, can look at the files that this container is running. And also I can do the same thing using the commands that we saw earlier. All right. So that's it. 12 cool app service tips and tricks that you can use to better use containers on app service. So thank you very much for attending, and good luck with your experience or your journey into the container world. Um, last awesome tip. Oh, headphones. It's a MPOW, MPOW headset that I purchased on Amazon. I think they're no longer available, but it was something cheap, like $50. So, all right. Thank you. Any of you have some questions? No question. All right. Well, thank you very much, everyone.